Hello, everyone. Thanks for joining our webinar. And we can start. As you noticed, this topic is microservices and how they affect actually scaling of your business. But I would begin with introducing Uplifting. For those who don't know our company, we are specializing in digital product development and technological innovations. And one of the interesting aspects of our company is that we are organized based on TL principles. So we don't have any managers and salespeople. So pretty much most of the guys here are IT guys. And last time I've checked, for the last 6 years on the market, we've delivered around 200 apps and was working with around half a hundred partners and customers. And as is right now, there is more than 100 active developers who working with us and living with us. And we are most prominent in finance, energy, retail, and IoT segments. So, and for those who don't know me, and I assume most of you actually don't, I'm geeking out about IT for as long as I remember myself. But officially, I'm in business for the last 10 years, and 7 of them, I mostly found myself in a position of a technical leader or architect, driving projects across multiple industries like media, gaming, fintech, and security. And I specialized in backend and front-end development, backend being predominantly JVM technologies like Java, Kotlin, Groovy, and so on, and doing also some hybrid mobile development and solution architect. And in my experience, I was working for the large companies that you probably know, like Burda Media Studios, or Česká Spořitelna, Legion. And I was also working for some startups, like, in Protagonist, I assume you even never heard about. And so today's topic, as you probably know, will be architecture, but not any kind of architecture. We'll be talking about microservice architecture. But what would be a bit different, I would like to put a bit of a different spin on this topic and more oriented less on a technology, but more on a business side of a question, and why it's actually architecture is even important from the business standpoint, and it's not just an IT people concern. So without further ado, let's jump in. And I would like to share with you my experience with working with a lot of companies, and mainly at the growing stage, and what kind of issues that they have. And for this reason, I invented yesterday my own company called Dream Beer, with a slogan "Only for you," that for the users who registered on their platform and with their consent and GDPR compliant and everything, is able to browse through all the socially and publicly available data, smash them into the machine learning and some mass personalization, and figure out what the beer will be the best for them, brew it, and deliver it to the door. So that's a business model. And as it usually tends to be, the organizational structure, especially the creation day or start day of a company, is pretty much simple. You usually have your product team who do all the business, who figure out what actually the customers want to have and how it should work, how to satisfy the needs of the customer, usually driven directly by CEO. You have your developer team that implements all of this, usually driven actually directly by the CTO. Then you have your developer team commits everything to a source code base. Then, as it's fashionable right now, you have continuous integration, and everything is being deployed to production. So that's really simple, and it's really simple to handle, really simple to develop, to test, to scale. You can just put it on Heroku, on some Beanstalk, or on Azure, and scale it almost infinitely. And what is important, it's really easy to make radical changes. What is more important for the startup? If you have a pivot, no problem. It's not that, but it's still painful, but it's not that painful to make drastic changes in your code base. And however, in a story of every successful company, there is a growth phase, because like either you grow as a startup or you pretty much cease to exist. And with growth comes challenges, because you need to satisfy more customers' demand or your investors' demand, depend on which positions you are. So you need to actually add more development and production capacities to your company to deliver all these features and all the new functionality of your digital product or digital service. But the good thing, the founders of Dream Beer was a smart guys, so they They know how it usually happens with the classical, more waterfallish approaches into development, and they decided to go more to the agile style of development, which pretty much defines that for every feature or the business aspect or domain of your business, you have a separate dedicated team, usually called autonomous, who consists from cross-functional specialists like testers, DevOps, front-end, back-end developers, and they all collaborate together, commit the source code, and again, it's everything driven through the pipeline of continuous integration and being delivered to the production. Well, it's actually more realistic today. You have your separate source code for the backend and front end, but it's not really the point here. What is the point is that at time, as more and more demand is put it on the company and you need to satisfy it, you need to deliver faster and more complicated features, you add in more and more developers team. And the problem with that is that sooner or later, you will find yourself in a position with actually your development in your company that used to be a startup, start actually to resemble more processes of a year 2000 in some average corporate environment. So why this is actually happening? The answer is surprisingly simple. It's a complexity. Your app and the functionality that you provide in your business domain, actually, as you dig in more and more and trying to find a more way how to optimize your ways, starting to become way again and more complex. And let's do one thing. Let's do something that not much people doing, except the IT folks, is we actually will take a look at your source code repository and see what's happening inside of a best beer production code. So the problem is, yes, best beer put emphasis on agile development, and they introduce a separate cross-domain teams. I mean, separate dedicated autonomous teams, but they're not so autonomous as it at first glance seems to be. The problem is the code inside the code repository is heavily intertwined, and every domain is really connected to each other. So this is actually creating a huge communication overhead between the teams. So they constantly need to consult each other to deliver the feature or the business aspect of your product that you required from them. But this is actually not the biggest problem. The problem is, as was mentioned, is that your system grew out of proportion and there is almost no one in a team who can understand the whole complexity of a business. And when a new guy joining your company, he probably will need years or months at best to understand the full scope of your project. And that leads to the fact that it's really hard to introduce for your teams new changes because they don't know what effects can happen. And if they introduce, there is a bad consequences can happen, then there is being tested, and then we need to find again what was the cause and actually how to improve the situation. And the thing is, it's relatively like the Thatcher architecture is relatively straightforward to test, and your testers can, especially the manual one, can test every feature you deliver. The problem is actually in such mess of a code, it's really hard to detect what was the source of issue, and you don't really know usually to which team even to assign the bug. And if you do know, it doesn't even mean that it was caused by their code and not effect from another team. And this is vicious cycles going on and going on. That pretty much because you have more teams that develops more code, it becomes more complex, and people need more time to understand it and be somehow productive in it. And plus, you need to spend a lot of time actually on maintaining this code, and it complicates. And pretty much the same thing happening even in your database. And a day-to-day basis, if you will think about it, that's actually a specialized name for such situation and architecture. It's usually called a spaghetti project or spaghetti code, or actually a ball of mud, because working with such projects, even for your business guys, looks something like this. Because developers always tries to untangle all the dependencies and tries to move the project to the direction that was required by the business. But then it's a common situation in such projects when the product team comes to the developer and guys, we need a new checkbox, and developers, yeah, we can implement this checkbox in half a year. And then it becomes frustrating not only for the developers, but for the whole company, because the speed of your delivery is significantly lower than it used to be, which, especially in today's competitive market, is having a great speed of delivery and quality of your service is a huge competitive advantage. So solution, well, as it stands by the name of the presentation, and to be honest, like, there was not much how to improve the situation back in the days. There was some special methodology, but as it goes today, the best approach usually tends to be a microservices. So I assume some of you may know actually what the microservices means, but just let's briefly recap, and maybe I will put a bit of a different perspective to it. So as I was saying, monolithic approach is demonstrated on this diagram. It's a lot of domains intertwined between each other, and there is no clear borders between them. Actually, there is no clear even the ways how they communicate and how they depend on each other in large projects. Microservices approach idea is really straightforward on a paper. Just put this domain in a separate boxes and define a clear API how they should communicate between each other. And to be honest, microservices has been really hyped recently, but this is not new idea at all. This microservices architecture derives from the service-oriented architecture or SOA that is usually being utilized in larger companies to connect multiple monoliths together, usually via such thing as enterprise service buses. And some actually even states that microservices is just a service-oriented architecture done correctly. And there is a few key differences between like the classical service-oriented approach that's still heavily utilized right now in companies with large projects, is that service tends to be way smaller. But that's actually a bit of a misleading, because a lot of companies get it in the fact that microservices means that microservice, a small amount of code in each service, and even some companies get it to the extreme where every service can be written, I don't know, in a matter of days, weeks, maybe max months. But to be specific, usually the size of a service is not as much defined as the size of a code base or the amount of functionality that it provides. It's better to define by the amount of people who can effectively maintain and make changes to the service. And usually it's a classical agile team, 5 to 10 people who constantly cares about this concrete service. And another actually really big difference from the initial service-oriented architecture is that microservices are really insistent on having a database per service. Don't get me wrong, not every service needs a database, but if it has some state and it needs to work with some state, then it has its own separate dedicated database. And again, it doesn't mean that you should have like multiple database management systems, like multiple MySQLs or multiple Oracles. You just need a different separated schemas in every aspect of it. And as a result of it, what you actually get on a more business and organizational level is the fact that every single of your team is dedicated to one, maybe a few services, but they becoming a domain experts on the services. So it really hugely reduces the cognitive load for your teams, because they right now don't need to understand the whole complexity of your business, just like a few guys, and not every developer needs to understand. And that every team has a responsibility for a certain slice of your business that they can operate and manage separately. And if this business aspect of your company and hence a team increases, you can just split it even more, and hence you have a great scalability of production of your businesses. You can deliver more and more complex digital products without losing effectiveness and quality of the services. And one of the aspects, however, that a lot of people forgetting about introducing microservices, and this is really important one, is that every service that you introduce to a system or to a digital product is actually have to be independently deployable. And I actually also add to this, it must be independently operatable. What it means is that whatever happens, there is no situation when, by introducing a new change to your product, you need to release multiple services. Like this approach is minimized to minimum. It's a really complex process, but if you will not keep up with this, what you actually will create is not a microservices. You will create so-called distributed monoliths. So it's pretty much the same huge complex thing that no one understands, but just split it into microservices and still heavily intertwined between each other, and still has a consequence that you need to deploy everything all together. And another like business view of this independently operatable of services is that it has a huge impact on your customers. Because if, let's say, you work in some e-commerce product and one of your services failed, and let's say it's a comment service, a service that represents for the comments to some particular goods in a system, the rest of the users will not see, like all your customers will not see a comment, but they still can browse your goods, let's say clothes or on a software technique or hardware, and still can order them without losing the full functionality of your digital products. So meaning, even if there is some failure in your system, you're not losing money by losing your customers. And this is actually one of the main aspect of the ideology behind the microservices-oriented development. And it sounds everything good and nice, but the problem is microservices are not that easy to adopt initially, on the contrary with a monolithic approach. And I will demonstrate three main, from my perspective or from my point of view, challenges that usually company tends to have. And this is how to actually even split to microservices, how they may communicate these microservices, and actually where is my data. And the last one will be interesting. And the issue is when you will try to decompose, even to create like microservice architecture in a greenfield or decouple your existing monoliths, decoupling it into the services is not really an exact science. It's more an art. And different architects for the same problems can even come up with different solutions, because there should be multiple aspects to it. However, there is one methodology, and to be specific, it's a domain-driven design. This is, again, it's not particularly new. I think it's from the beginning of 2000s, that can guide you through this process. And the way how it does it is that it tries to find a bounded context, isolate these bounded contexts, and define the communication between them. So it pretty much reminds you how the services should work. But what is exactly bounded context? Well, I will be probably blamed for oversimplifying things, but in a really high-level view, it's like, imagine if you would organize your business, not your IT, you will organize your company, you will probably have your sales department, and you will probably have a support department. And both of this department, what is interesting, and if you will observe people working there, have a slightly different goals, a set of goals, and slightly different perspective and language about your business. So example could be but they do need to communicate with them, with each other. So like example could be that if your support department find some large amount of complaints about your product, or maybe some critical features missing for your customer, that can transfer this data. And this is usually happened by creating, let's say, a Jira ticket, or just with a cup of coffee on a meeting. They transfer this information to the sales department, because the guys can actually take it as an opportunity and improve your product further. And this is pretty much exactly the same what DDD tries to achieve. But on the level of architecture, it tries to understand your business and map it to the architecture and code. Why this is important is because if you will think about it, and I'm not talking about right now science or other branches, most of the development right now is happening is nothing more than automatization of human interactions, or hence business interactions. So you need to understand your business in the first place to be able to automatize this. And it's actually what this DDD tries to achieve. And this is actually tries to achieve by decoupling into the different departments and setting a clear communication channels, and a really strict one, between each other. Additional interesting aspect of this is that every single bounded context has its own representation of global entities, let's say. And again, just not to go to the technical details, there is probably somewhere in your database an entity called customer. But DDD recognizes that customer for the sales department is something completely different from than your support department. Don't get me wrong, it's still the same person, but the amount of the attributes that the both departments are interested in are completely different. And usually in operations on the entities also different. And bounded context, like the question if bounded context exactly mapped to your services is a long debatable, and I would argue that not exactly, but it will give you a really good example how to actually map your use cases into the architecture, and then like even further maybe split into the more concrete bounded contexts. One interesting aspect that also this DDD approaches is creating or evoking is a problem that probably was prominent for the last 20 years probably in a development, maybe 10. But what I'm talking about is that usually the development tends to be so-called data-driven and not in a good sense. It means that usually when your developers or your IT guys get some new requirements, the first thing they do is they establish a data model, how it should be stored in database. And then they figure out how the business logic should work and how we should present it and so on. That has some certain disadvantages at a large scale. Without giving much into the detail, what DDD does is actually puts your business in a core, as is presented on the right diagram, in a core of architecture. So what DDD tells you is like automatize the business first and figure out how it should be stored in database and how it should be presented second. So everything except like automatization of your concrete business key doesn't really matter. No matter how exactly you will automatize it. It's a really interesting approach for the development of large complex systems. Additional hint that starting to become prominent on a field of architecture is a new approach called event storming. It's actually heavily based on DDD and was created by Alberto Brandolini recently. It's actually a methodology. It's a meeting, quite a long one, with a lot of involving a lot of sticky notes and collaboration. We utilize it sometimes here in uplifting, and it's really good at mapping large complex domains and finding bounded context and how they communicate between each other. Again, not gonna go in much of the detail. Please visit the website. There will be more information about it. But the main point here is actually that the event storming is heavily insisting on putting the IT specialist and domain specialist and your business specialist into one place and facilitate the communication between them and telling how they should communicate and guiding the process. So why should you care about all of this? Like, why should you care how to split the business? Well, it has a certain effect. In order to, even without going to the microservices architecture, I would heavily advise you to pretty much make your business and a dev as a best friend forever. They should have an ambiguous language. They should communicate the same language about your business domain in order to actually automatize. As I mentioned before, you cannot automatize something you don't fully understand. And having a common language is really important here. Plus, it actually will give to both of your teams a really feeling of old startup times because it's tight business to development collaboration. Next aspect that people usually have issues with are like the first question that they have about service-oriented, microservice-oriented architecture is actually how make things communicate. Yes, we split them into parts, but like how they should talk to each other. It's understandable. On the market, there is a lot of tech right now that provides different styles of communication. I will not go again by detail because it's actually not important. What is important is there is pretty much two major styles of communication in any distributed system, be it peer-to-peer, service-oriented, microservice, doesn't really matter. There is asynchronous communication, and you can imagine it, if you was even given some tasks to people, is that you have a task, you need someone to execute it, you come to this guy, you put a task on a table, sit and wait until this guy executes the task, take the result, go to the another guy, sit with him again, wait until the task is done, take it, and so on and so on and so on. So this is why it's called synchronous, because you're pretty much sitting and waiting until task is resolved. And usually it's represented by such players as GraphQL, REST, and gRPC. I think the predominant will be the REST because it's highly adopted and it's really simple. And a lot of actually distributed system goes for this protocol, but I would argue it's actually may not be the best approach. There is a couple of reasons for that, but the major is that REST has a tendency to force people to map all the business operations only to the CRUD, basically create, read, update, delete operation, which is not the case. It's really not that convenient in expressing your real business value that you wanted to express via this operation. gRPC is actually a really interesting alternative. To be honest, I don't have much experience with it, but it's more flexible in this manner. On another hand, GraphQL is my favorite cup of tea, and it's really compensate for the lack of REST flexibility, because you can imagine it's pretty much like SQL on top of your API. The issue with it is actually GraphQL tends to be quite complex on handling if you will not bound it properly. And the major issue that the tooling around GraphQL is not that grow up yet. Most, for example, it's really hard right now to make a load balancing of a GraphQL or monitoring of GraphQL. There is a tools for that, but usually they're oriented for the Node.js or JavaScript environment, and there is less prominent support in Java, Python, or Go technologies. Another style, the second one, is asynchronous communication. And asynchronous communication is like when you need someone to do something, you write him an email and then go. And then he someday in the future, he will post you a result to your mailbox. Or you can send multiple emails to multiple guys to execute some task. And that's pretty much all of it. And the only difference here is that instead of your mailbox, you have so-called message broker or event bus, usually represented by such players as Kafka, ActiveMQ, or RabbitMQ. The most predominant right now is actually Kafka one, because it's really durable and incredibly scalable, and is capable of moving huge amounts of data really efficiently and across multiple services. But again, without going much into the detail, what the main point here to understand is that synchronous communication is really low cost for the adoption, because everyone knows REST and you don't need anything for this. But it tends to have a lower scalability and lower availability in the future. So it's, as you will as your system will start to grow more and more, it will be harder and harder to scale it. Asynchronous, on the other hand, requires you to have a central component like Kafka, ActiveMQ, that you need to set up, to scale, you need to secure it, they need to manage it. And plus, it becomes like not a bottleneck, but a possible centralized point of failure, which for Kafka compensated by being distributed. But that it gives you almost infinitely scalability and availability between the messaging, between the components who sits on two sides of a pipeline. So usually, actually, companies utilize both approaches. Actually, it's I rarely saw that some goes only synchronous or only asynchronous. There is some kind of tendency right now to go only asynchronous, which is good, but there is a certain cases where asynchronous communication is way better for handling stuff and way more cheaper. Oh, this is actually my favorite topic, because I think this is the first issue that developer who usually says to the startup, hey, let's go with the microservices at school, face with, and it's actually one of the most complicated one. The issue here is that some of you may know, most of the databases and places where we store like classical relationship databases has this property called ACID. So it means it's acronym for the fact that all the operations that you put in with your databases are atomic, consistent, isolated, and durable. In a nutshell, that atomic means that something happens or not happens at all. Consistent is that all your business rules will be preserved. Isolated means that if two transactions or two operations happens at the same time, nothing gonna ever collide. And durable means that data is not going anywhere. And it's this, if we'll think about it, this is actually guarantees, really hard guarantees that was covered by its database. And the problem is, a lot of developers, and me personally, are pretty much stuck on ACID. We get used to so much trust in our database, and it facilitates so many troubles with handling data that, for example, with such approach as demonstrated in a diagram, when you have your only backend and a database, it's really easy to make any changes. You start in transactions, you update multiple entities, multiple domains, you end your transaction, and then if some other user needs to do it, the same thing happens. And if two transactions happens at the same time, database is going to resolve it for you, no worries. Okay, not in all the cases, but usually it tends to be like this. And everything was covered and by Oracle's, MySQL's, or other relationship databases. But now we have a problem. As I stated previously, microservices, to enable them be independently deployable and operatable, one of the key elements, you need to have separate database per service. But the thing is that we right now communicating over network, which is unreliable. Network can fail anytime. Packages can be lost. Service can fail at any given point. And even actually, you can even get a message to your point, but not get any response. So what to do with this situation? Well, it's called distributed transaction. And that's not, again, it's not a new topic. It was for a while. There is different options how to resolve them. The first one being OpenXA, or so-called two-phase commit. It's utilized heavily right now again, in more larger like financial environments. And it's good, don't get me wrong. I will not go into much details, but what is important to understand is that in OpenXA must be supported by the database itself, and it's usually only supported by the relationship database, so you completely loses an option to use NoSQL databases, like entirely. And plus there is required a specialized transaction manager. Additionally, what it does is that for every component involved in transaction, it locks the data at the database level during the as transaction goes to guarantee independent of operations, so they not collide with each other, to guarantee isolation of your operation, so-called based on ACID definition. And the problem is it's usually this is happening also in a synchronous way. And that leads to really interesting consequences, is that components that participate in this distributed transaction, the availability depend on each other. Or to be specific, the availability of this concrete operation that triggers distributed transaction becomes a multiple of availability of every single component. Let me give you an example. I know maybe it's a bit more mind-boggling to explain without the images. But let's say you have 3 components, and every of them has availability of 99.5%. Not bad, not bad at all. But then you need to involve all of these 3 components in one single transaction. Let's say making an order. The problem with this approach is that right now the availability of your operations is 98.5%. And if you will calculate, it means that your business is at risk daily of being down for 20 minutes. So don't get me wrong, this is a good approach, but it cannot be scaled infinitely, and it's not suitable for every kind of operation. Another approach, again, it's starting to be adopted quite, like it's relatively new for adoption, but definition of this process is quite old. I'm not sure, but I think it's from year 70 or something. Again, I will not explain exactly how all these gears are moving. I think this is not the main point here, but what is important to understand is that Saga works in a manner when in every component that participates in transaction, it immediately commits data into the database, and then to another, and then to another. And if something failed along the way, let's say one component cannot respond or wasn't able to process request, you need to evoke so-called compensation transaction. So it pretty much means that you send another transaction on top of previous one that will change the state of your system to the previous as it was, as like nothing happened, but the data will be still in database. Plus, the Saga usually relies on asynchronous communication like message brokers or Kafka or ActiveMQ. And it gives really interesting consequences is that you pretty much drop out two properties, or like relaxes two properties of the classical ACID approach, which is you completely loses isolation. So yes, in Saga, and this is one of the hardest part that people who are familiar with Saga don't quite realize, and the Saga can conflict with each other, meaning if there is two transactions, they can corrupt each other's data or lead to incompatible business state. And then there's actually what is interesting is actually eventual. So your data will be consistent, but you don't know when. Don't get me wrong, doesn't mean it will take hours. It usually takes milliseconds, but you don't know exact moment. So again, just don't scare you off. This was probably the hardest part of all of this presentation. Why should you care? The main point here is that distributed transactions are really expensive for implementation. You need to minimize them in a system, and there is a way how to do this. Another thing that is probably bigger companies get used to, but is a bit stressful for smaller companies, state of your business is spread across the multiple databases and maybe not normalized. So imagine how it's going to affect your, let's say, monitoring auditing systems. Full ACID, like the full, like this rigid system and all the data that goes to the system are directly there, no one can corrupt them, reduces availability. So the more you have it, the less available your service, making you more and more at risk of your whole infrastructure being down. Eventually, consistency, like an example with Saga, provide you great availability. But what you lose is actually consistent state of your business. You don't know quite when the data will be in the consistent state. And let's just wait here for a while, because if it seems if it's a big technical issue, it's not quite, because it will affect how your business even function and actually how you should think about delivering value to a customer. So let me give you an example. With a classical, let's say, ACID approach, or let's say two-phase commit or in a monolithic architecture, usually when, for example, user makes an order on your system or wants to create a payment, he will immediately get back as a result of his operation. Either it was successful and the payment order is accepted and everything is fine, or he gets an error. That's a usual case. With the eventual consistent and more Saga-like approach, the situation is a bit different. Your customer can request to make an order and to make a payment, but the only thing he will get is like, okay, meaning we accepted your request, but we don't know the result yet. And the result that will be known sometimes in the future. And actually, if you think payments works exactly like this in any internet banking. But this is a bit different mindset and thinking about value adding to the customer during the designing of your feature. And well, let's face it, like developers, even me included, we are hooked on ACID, we get used to working it. And the fact that we will need to resolve all of the situation on manually, let's say, is a bit tough here. And well, just the last point, don't forget about the human side. Establishing new architectures, approaches, or adopting them, or any processes will be stressful for your company, and you will need to drive innovation in your company, like to make people adopt, understand, because people will need to actually unlearn a lot of things, how they used to do it, and learn a new fact, which depending on a personality and let's say life views of a given worker can be tough or easy for someone. But if you're interested in the human side, call these guys, they actually really know how to do it in IT environment and how to move your company from point A to the next generation. And to be specific with microservices, it's not far from being all the challenges that we have. There is also security, there is monitoring, auditing, how you're going to even test all of this. And a good place to start, actually, if you're really, really interested in considering to having it for your company, I can see the benefit. I will really advise you to read the books by Sam Newton, Building Microservices, or Chris Richardson, Microservices Pattern. I think it's a really good and solid end-to-end solution, how you should think about it and how should you drive the change. or I will be glad if you will give me a call. I will be glad to chat about it. Maybe I will give you some of my insights and help you out to adapt you for your particular case. Definitely give me a note. We'll be glad to chat about it. So let's wrap it up. Microservices are hard. And this is actually a graph, a chart from O'Reilly's study on 1,500 participants, I think, from the companies who did adopt microservices. And as you can see, one of the top one that was mentioned in the last one is overcoming existing mindset. You need to start thinking differently about this infrastructure, not only on IT level, also on business level. Then there is, for example, things like how you're going to decompose, how you're going to make them communicate, how you're going to secure them, how you're going to monitor them. And actually, it still preserves a complexity on, let's say, but on a higher level, but makes it more manageable. But the interesting thing, if you will look at the bottom, the financial investment was the least worrying factor from all of this. The good thing is actually that you will get a great feature flexibility. You will be able to quickly respond to the market demand, really easy to scale. You can even auto scale depending on a time, which can greatly reduce cost of operation. You can quickly fix anything and actually still can really experiment. You give a field for the experimenting. You can introduce new changes, new features, new technologies, upgrade stacks, do A/B testing, which is probably also almost impossible with a monolithic approach, or really, really costly. What is important, and from, I think, one of the main important points of all of this webinar, and a lot of people, from my experience at least, don't really fully understand it, that agile communities, especially in a corporate environment, was really, really active and pushing a new way of organizing your IT and delivery, especially in the large companies with a scaled framework like LESS or SAFe. And they was promising that by restructuring your company, you will have a better speed of and quality of software development and better processes, hence having a better digital product or service. But don't get me wrong, they actually did a great job and it did move to the whole community forward. But the thing is, it's only half a truth. Or to be specific, this is actually a sort of a truth. As it's visible from the diagram, architecture is actually main enabler for your organizational structure. So, and architecture is also main enabler for the processes in your company. And all of this must work together to enable you rapid and frequent reliable software delivery and delivering like a rapid value to a customer. So to give you an example, really, let's speak frankly, going to the microservice architecture without autonomous agile teams is like to try and launch a spaceship with a horse. On another hand, having autonomous teams like agile teams without microservices is like trying to feed your horse with a solar energy. Just like doesn't work together. Your whole operation must work coherently to enable you delivery over necessary quality of your product. And if you're still asking yourself like, hey, but probably microservices only for the large infrastructure, not quite so. I mean, don't get me wrong. I will strictly I will not recommend anyone to start up with a microservice. It's a really bad idea because A, you don't have enough money to do this, and B, you actually, getting back to the decomposition problem, you don't even have an idea how your business is going to function. So how can you automatize it? So rather go with a monolithic approach. But there is a certain point in time when actually your monoliths will drag you down. And this happens sooner or later, actually, depending on the speed of your business and or growth of your company. And at a certain point, it's actually without investing, you will lose your quality and you will lose your performance and you will lose the ability to quickly adapt to market, which is insanely significant right now as any new services is coming to the market almost every month, every year. And you have quite a huge competency on this market. While microservices actually have a really requires initial investment, but give you way higher degree of scalability and field for experimenting with your product and deliver a great value to your customers. So, but if you will ask me, what is actually the main ingredient? If I would go and decided, okay, this is the time, this is a moment of my life, and I need to go starting doing microservices, my company, to enable all these goods of it. What is the main ingredient? Well, as it usually happens, the main ingredient is always a great people and great engineers. So thank you for being with us. I'm looking forward for your questions. Let's open a Q&A session. So if you have any, please feel free to post it in a Q&A. And meanwhile, I actually will post my contacts for people who would like to chat a bit more about microservices, maybe. Yes, Igor, thank you for the good feedback. The record will be available, and I will send it. We will send it to your email, I think somewhere during the week. Okay, and I'm just realized I didn't understand how to put any messages here, so. Oh, here's the chat. Thank you, guys. So there is my contacts in the chat. Feel free to ping me or call me. Or actually, with the last link, you can even book a meeting with me, and I will be glad to check about your situation and maybe give you some hints. Or actually, we'll be glad to learn about your experiences. Okay, so I think there is no more questions coming. Thank you everyone for joining. I'm really glad you was with us. Hopefully you enjoyed the presentation. Okay, there's another question. Let's say there is a new startup and they decided to go with analytic architecture first and they are planning to switch to microservices later. What can the startup do to prepare for the switch to microservices later? I imagine it's quite costly and afraid to switch to microservices. Well, that's actually a good question, Honzo. The thing is, there is not much you can do. If you will prepare, like there is a potential, like what you can do best is to apply DDDs even to your monolithic approaches. The issue with that is DDD and as a coding practice is a bit more expensive. It requires a lot more effort to deliver a value. And I'm not thinking actually as a startup time, it's a really good moment to care about such things. Most of the startups, let's face it, are failing. And right now, your biggest priority will to actually make a working business model. And as you will have time in the future and more resources and ability to hire more great developers, then I think it's time to care about it. Okay. Okay, guys. So I think, like I was said, feel free to ping me. Thank you for joining our webinar. I hope you like it. We'll be glad if you're going to join our following webinars. We will be starting to do it periodically. So have a great day. And again, hope you enjoyed it. Bye-bye.